possible. And then we are going to look at a sample grade 4 performance task, all right? So bear these objectives in mind as we proceed through the session. All right. Now, you may be wondering what are some of the domains that are measured by PEP. Now, you will be tested or you'll be assessed on concepts and procedures. I think most of you would know this part. You know, you're tested on problem solving. And so you're given a task that requires you to think it through logically and come up with some form of solution to the problem. Maybe a model, and this can be done. You may be required to use tables and several other ways of modeling. Also, you may be asked to analyze some data, all right? And fourthly, we'll be measuring your communication, all right? And you may be thinking, oh, I don't like to write a lot, etc., etc. But communication is more than that. It's more than just writing. For math, it may be using an equation, it may be using a model, it may be using words as well. But what's most important is that you are expressing yourself in such a way that the person who is reading what you have is understanding what is happening in your head. What is it that you are thinking? All right. So at no point in time should you be just putting down an answer. All right. Because with an answer, the person who is looking over your paper will not be able to determine thinking or how you arrived at the answer that you have put down. All right, boys and girls, so ensure that you communicate clearly your thoughts. Okay, now as we continue, you would have heard that PEP test problem solving. And so we're just gonna share with you some problem solving steps and also some strategies that you can use. All right, so whenever you get a problem, boys and girls, ensure that you understand the problem, make sense of it, read it, see what is happening, what the context is. Is it a fundraiser? Is it something for you to tile somewhere? What is it that you're being asked to do? Ensure you understand it well. And out of that, you devise a plan. In other words, you decide, what is it that I'm going to do? How am I going to answer this question? What are some of the steps that I'm going to take? What operations will I be using? So you devise a plan, all right? And then you execute the plan or you carry out the plan. You're gonna actually do what it is that you said that you were going to do. So you carry out the plan, all right? And most importantly, I always say, look back, because guess what? Sometimes it's not your plan that has a problem, you know. But in executing it, you made some error sometimes. All right, so double check not just the plan, but double check also the calculations and see if your answer makes sense. Is my answer a reasonable answer for this problem? And of course, if you notice that it's not, then notice the arrow goes right back to understand the problem. It means that something is off in what you thought the question was asking, all right? And so you have to go back now, reread the question and ensure that you understand what it is that you are being asked, all right? So that's the approach. Now we have some strategies, all right? Just about 8 of them. We won't be going in depth because we have a lot to share with you today. And so we're just going to be sharing these 8.
If you ask yourself.
Choose an operation, please mute. I'm not sure who that is. All right. Now, choosing an operation, we tend to use this one a lot. Immediately as we see a math question, we think, you know, what operation am I going to use? But not all the time, this is the first approach to take, all right? There are some instances where maybe you need to draw a diagram, perhaps, all right? to see things a little more clearly. Yeah, there are other times that you may need to find a pattern. And let me tell you something, boys and girls, in math, a lot of patterns will come out. All right. Sometimes, in order to see a pattern, you may actually have to use a diagram in order to see what pattern is coming out. All right. And another time, you may actually end up making a table. That one will come up later on. But sometimes a table is what helps you to see the pattern because you're now organizing the information and you're able now to see something that is common through all that is taking place. Other times, you may be asked to make a list, right? Or you may have to use a list in order to solve the problem, all right? Sometimes you may have to work backwards and you may be saying, work backwards? What Miss mean by that? But maybe the situation is that you know the amount of money that you have right now, okay? Having spent quite a bit, you purchased box drink for such an amount, and you purchased a patty, and you purchased something else, and what you have left now is $100. And the question is asking you, how much money did you start with? So you have the end product, you have the $100, and you have to work your way back in order to figure out what was your starting point. How much money did I start with? All right. You may also be guess and check. Notice, as I always say, it doesn't only say guess, it also says check. All right. So even if you make an educated guess, you have read the question, and in your mind, this looks like a reasonable solution. Always ensure that you check. And the checking is important. It's not just to determine if your guess is correct or not, but it also helps you. By looking at it, you will know if your guess is too far below, it is way more than what it should be. And so it helps you to adjust your guess. So this particular strategy would be a little repetitive, because if you guess and your check reveals that there's something off with this guess, then you have to take another guess and check. But ensure that when you check, you're not just saying, oh, this is not right, or but you go back to see, okay, it was too much. That means my next guess should be a smaller value, or this was too little, so my next guess should be a larger value. And finally, use logics. As I always say to my students, mathematics is logics, not magic. All right. So ensure that whatever it is that you are doing, it makes sense. You think about it and follow through logically. So having said that, remember the objectives. We said we are going to be taking you through some sample numeracy questions. But just before we get into those, we want to take a sneak peek at decimals. All right. So this is where you are going to get to type in the chat, and Miss Williams, who is presenting with me, and the other persons on the platform will assist me if there is someone who needs to speak, and we'll decide who that person is, and you'll be asked to unmute at such time. All right, so a sneak peek at decimals. On screen now, I have a square, and this square is representing one whole. So I'm going to repeat, this square is representing one whole. Now, I've taken this whole and I have divided it, cut it up if you want to use that term, into 10 equal parts. I want you to type in the chat and let me know what would be the value, or I could ask you for the name of one of those parts. All right. So I have one whole and I've divided it into 10 equal parts. I want someone, anyone or all of you, let me see the chat blowing up. What would be the value of one of these parts? right?
So
I see something.
Karine
Okay.
Barnett says it's 1/10. Khalil Howlett says it's 0.1, 0.1.
All right, interesting.
Right, I'm getting quite a few 1/10.
All right. Okay. And I'm seeing the chat blowing up a little bit faster with 1/10. Awesome.
Mrs. Mundell
Awesome.
Thomas, I'm
Yes,
seeing
Mrs.
1/10
Darby.
written in many different ways. I see 1/10 as a simple fraction where the
Mhm.
numerator is 1 and the denominator is 10. And I also see 1/10 written as the number 0.1. So they are writing 1/10. Yes, Cameron just wrote in 0.1, which the number name for that is 1/10. So there 1/10 is being said in a number of ways.
Awesome. Thank you so much for that, Mrs. Darby. Good. So 1/10, we're seeing it written using the fraction bar, and we're also seeing it written using a decimal point. But however it is written, it is still referred to as 1/10. So even if it's 0.1, it is called 1/10. Go ahead.
Miss Mundell Thomas, I saw where 2 students have also written 1.10. I want you to shed some light on this for them so they can leave with the correct way of writing 1/10 as a decimal.
Okay. Thank you so much for that. All right. So you said 1.10?
Yes, it is.
That's what you said? Okay. So my question to such a student, I didn't see who it was. I would be asking, first of all, if the value of one of those parts, if that would be greater than one whole or less than one whole, because I would be concerned about that one that is there right before that decimal point. That would be of concern to me, first of all, right? I'm hoping it's an error, selecting the point instead of the fraction bar, all right? But remember now that when we are naming our fractions, we would usually determine, first of all, how many equal parts my whole has been divided in. So if we look at the whole on the screen, that is 10 equal parts, all right? So the whole that's on the screen is 10 equal parts, and so my denominator, or the denominator I'm going to use, is going to actually be 10. And now if one of those parts is highlighted, thank you, Miss Williams, she has highlighted one of those parts. It's now one part out of 10 equal parts. Notice the word I'm using, equal parts, and that's very, very important, students. All right. Now, I have another question, Miss Williams. So I'm looking on the screen and I notice that the whole that is there was divided into 10 equal parts, and we agree that that part that's shaded is representing 1/10, one part out of 10 equal parts. What do you think should happen if I should further divide this whole? Each of those tenths are being divided into 10 equal parts. Can any bright student type in the chat and let me know how many parts would this whole be divided in?
The question again is, how many parts or how many equal parts will the whole be divided in? And there's a reason for repeating the question, because I'm seeing persons putting in 100th in the chat. So I'm seeing the fraction 100th. Listen to the question again. How many equal parts would the whole be divided in? Remember, you have 10 equal parts now, and we're going to divide each of these parts into 10. How many equal parts will the entire whole be divided into?
All right, I see some person self-correcting, Miss Williams.
Definitely.
answering the question that was asked. Very important that we pay attention to what was asked and not what we think should be asked. All right. But I'm seeing someone saying 50. Can we bring up a visual, Miss Williams?
Certainly.
So we
Will
can
do.
actually see what this looks like. All right, so the whole is there. It was initially divided into 10 equal parts, and we have now divided each of those 10 parts into 10 equal parts. Again, how many equal parts is the whole divided in? That was a question, and I saw some persons typing 100. Awesome. Some persons are running ahead, Miss Williams, because they assume what we're going to ask next. I'm going to presume that that's why I'm seeing some of the other things coming into the chat. All right, so I'm going to go ahead and just ask it. All right, so you're going to now tell me in the chat another way, or what could I now call the part that is now shaded. So it is now 100 equal parts. How many are shaded, and what would that fraction be? I see Xavier Brown with his hand up. Not sure if he's answering the question. Could you allow him to unmute and share? Is that Xavier?
Ours is 10 out of 100.
Okay, 10 parts are shaded out of 100 equal parts. Awesome. And I see another hand I'm going to take, and then we continue. I'm seeing what's in the chat. Karine Bennett, go ahead.
Miss, I think 10 out of 100.
10 parts out of 100 equal parts. Awesome. All right, I see my PowerPoint has disappeared. It seems as if Miss Williams has been disconnected. So I'm just going to start screen sharing. One moment. All right, so I'll just continue to screen share until Miss Williams returns. I'm not sure what's happening with her internet. Are you able to see the screen, boys and girls? Let me know in the chat.
Yes, we are.
Oh, thank you, Mr. Leary. All right, awesome. All right, so that's getting us to where we are. All right. Thank you so much, students, for responding. Okay, so 2 persons would have responded using their microphone, and quite a number of persons responded in the chat. And yes, you are correct. All right. And there were some students who gave this version 1/10 written with the decimal point. Notice there is an equal sign between all 3 of these quantities: 1/10, 10/100th, and I'm going to say 0.1, which is also pronounced or named 1/10. I'm saying it like that just because of how it's written on screen, so you can see all 3 of these quantities, boys and girls, are equal. Notice it's the same portion that's shaded on screen. We didn't change it. All right, that's very important. I'm gonna move to another one, and you get to tell me in the chat what quantity is being represented, or what part has been shaded. All right, and I see somebody out of the blocks very early. Mackenzie, are you sure You want to count those hundredths again? All right, and the chat is blowing up, guys. Can I tell you? All right. Okay. Awesome. I saw someone, chat is moving so fast, but I did see someone with 1700, and I saw 1, then a decimal point, and then 7. All right, so remember now, we have to be very, very careful. Okay, we have to be very careful because 1700, and as we're looking at the screen, we realize that that's actually less than the whole. Remember, the entire square, that large one that we showed first, is representing one whole. All right, so if you have 1 and then a decimal point and then 7, you're actually giving me a quantity that is greater than one whole. All right, so remember to think about these things as you are giving your answer. Xavier Brown, your hand is raised. All right, Higgins, please double check that response that you're giving in the chat. Xavier? All right, I'm not hearing Xavier. Bennett, your hand is up to answer this question or to say something. Go ahead quickly.
Yes, I think it's 17 out of 100.
All right, I hear 17 out of 100, or in other words, 1700. All right, so that one with the TH. I hope I'm sounding it as clearly as I can. All right, so remember now, we haven't even started the questions yet. So let us see if we can run to another example, one final one. So those of you who typed in the chat, awesome job. There are maybe 1 or 2 persons who may need to, do a little correction. So notice what we have here, 1700, and notice how it is written when we are writing it using our decimal point. All right.
So Mrs. Mundell Thomas, you're saying that those 2 numbers on the board are called in exactly the same way?
Exactly the same way. They are written differently, but they are pronounced or named the
Number
same
name
way.
is the same. 1700 is equal to 1700.
1700.
Got you. Clear.
Thank you so much, Miss Darby.
So, and the TH would be at the end. 100.
At the end, I've been trying to ensure that, I look the part. Yes.
Okay,
Right.
thank you.
You're welcome. All right, Miss Williams is back. I'm going to allow her to continue to screen share after I'm through with this slide. All right. So let's do one final one, and then we delve right into the questions. How about that one? And I know the chat will just be blowing up now because we've got this. We definitely have it. All right, and Aiden is out with a bang. I can't even follow the chat. Awesome. All right. Okay. We're on the same page, and I'm seeing different ways of writing the same quantity. Awesome. Okay. I didn't see one particular one, so I'm gonna allow you to look on screen. All right. So I see 20 hundredths. Very, very popular response. 20 hundredths. Same 20 hundredths. Look at the screen now. Look at the screen now. Look. It's the same 20 hundredths. I've just decided I am not going to be working with 100 equal parts anymore. And I've gone back to 10 equal parts. Is it the same quantity? Let me know in the chat. If you think it is the same quantity, type yes. If you think it's not the same quantity, type no. I'm trying to follow the chat to ensure I pick up anything that needs to be addressed. But I don't see anybody saying yes or no.
I saw
All right,
one
so I hear
person
same.
type yes. One person typed yes. And so it's so important, children. I know you're busy typing the answer, but we also have to pay attention to the instruction that was given. So I'm seeing yes and I'm seeing no.
No.
Yes and no.
Interesting. Interesting. All right. So let's see if we can clear up. So we are all on the same page as we move into the set of questions. We don't want to stay very long here. All right, boys and girls. I see your responses. You can stop typing now. Let's look. Let's look closely at it. All right. So here we had 20 hundredths. All right. We would have checked. The whole is divided into 100 equal parts. And if we counted those blue squares, smaller ones there, we would get 20. Now, all I've done is to combine 10 of these hundredths together, and I've simply now gone back to dividing the whole in 10 equal parts. How many parts are now shaded? And quite a few persons answered in the chat already. You don't need to answer again. You would have indicated 2/10. All right, so 2 parts out of the 10 parts have been shaded. Now I'm going to, all right, so I see Aiden and Sahid, beautiful. All right, so the 20 hundredths that we saw earlier, notice the shape has not shifted any at all. The area that was covered with blue has not changed any at all. And we can use those ideas to help us to see if the quantities are the same. All right, so it's the same whole that we divided initially into 100 equal parts. And now we're saying, we didn't want it so small. And so we combined and said, we're going to just divide it into 10 equal parts. And it's the same portion that has been shaded. All right, boys and girls? All right, awesome. So remember now, we talked about the equal sign, and we'll speak a little bit more about it. So as Miss Darby pointed out earlier, 20 hundredths, same quantity as 2/10. Whether it's written with the fraction bar or it's written with the decimal point, it is still pronounced 2/10. All right, so I'm going to allow Miss Williams to take over screen sharing duties as we continue.
Ready for you now, Miss.
Thank you. I have to just be so alert on the online platform, I tell you. All right, so we're up on our first question. Now, based on what we just did, I hope you were paying attention, because the question 1 and 2 will pull on the information that you learned just now. So the question is, which of the following is equivalent to 3/10? So before you put up your hand, I'm going to ask you to let me know in the chat what you think equivalent means, because I didn't use that word when we were talking earlier. What does equivalent mean? And I see people blowing up the chat with the answer. That's not what I want yet. What does equivalent mean? Are they asking us? All right, so I see the same and I see equal coming out. All right. So I see quite a few answers. I saw B, I saw C. Don't remember if I saw A or D. But let us see if we can identify, because this is not just for you to tell me the answer. We also need to be able to identify what each of these options are showing to us. All right. So let's go with option A. I hope you're listening to the question I'm asking. Option A, what is that diagram or that model showing us? What quantity is that model showing us? So I don't want the answer as yet. Destiny Smith, your hand is up. Can you tell us what model A, what quantity is A showing us?
A is 10 hundredths.
All right, 10 hundredths.
I don't
Is there? All right, thank you, Destiny. Anyone has another way of expressing that? What is option A showing us? What quantity, what fraction is it showing us? So I heard 10 hundredths, all right. Is there any way that that could be further simplified? I hope you would have used that word. All right, I see someone typing in the chat, 1/10. Do you agree with that, Miss Williams? Someone said 1/10.
I am in agreement, depending on how they are looking at it.
I'm in agreement too, but explain what you mean about depending on how they're looking at it, and then we move on.
So if they are looking at equivalent fraction, it could be seen as 1/10. So first of all, they could see, let me get my highlighter here, so they could actually see what I'm talking about. They could see 10 equal parts coming down. 1, 2, 3, and as we go along, 4, 5, 6. And so, yes, they could count this as 1/10. Also, if they simplify the 10 hundredths, they will also end up with 1/10. And how do we simplify? We find a number or a factor, let's call it the correct name. We find a factor that can go into the numerator as well as the denominator. And that for me is 10. I use the greater factor. 10 into 10 goes 1 time, and 10 into 100 goes 10 times. And so 10 hundredths written in its simplest form is 1/10.
So what you're saying is I could see it from the model. I could see 10 equal parts going vertically as you showed us earlier, which is similar to what we had on our diagram earlier, correct?
Exactly.
All right, awesome. Okay, what about C? What is C representing? And Nigel is jumping the gun and giving me the answer what D is representing. I see it, Nigel, but you're going to tell me what C is representing because that's the one I'm asking for right now. All right. Kimona is answering, Carrie. All right, and I see the chat blowing up. 300. Awesome. What about D? So Nigel gave me his answer for D already. Anybody else? What's D showing us? Somebody said a half. Yes, Miss Williams.
I'm going to go back a little to B because I'm sure I heard 300.
No, I said C. C. I haven't done B yet.
Okay. All right. Beautiful.
I saw 50 hundredths for D, and I also saw a half. Can anybody let me know if which of those answer is correct? Is it 50 hundredths? Is it a half?
I think this group of students understand equivalent fractions because we're getting a variety of correct answers. I see some answers that are not correct, but I'm seeing a variety of correct answers expressed in various ways, as decimals, as fractions, as reduced fractions. This looks good, Miss.
Looks awesome. I'm impressed, Miss. And so we can nail down the correct answer here, and which, as you would realize, I purposefully left out B. No. So I saw some incorrect answers earlier. I hope that now that we have looked at the value for each model, that we would see clearly why B is our correct answer. Ms. Williams, go ahead and put the value that we have here. What is B representing, just so that everyone is able to see.
All right.
And then we move.
Okay, not a problem. I could write that in so that they could see exactly.
That's what I wanted.
We have 300, 30 hundreds, as some persons would have written in the chat. But 30 of those little squares have been shaded. So we have 30 hundredths. And why is it 3/10 are equal to 3/10 are equivalent to 3/10? Again, we can simplify by saying, find a factor that goes into the numerator and the denominator. And that for me is 10. So 10 into 30 goes 3 times, and 10 into 100 goes 10 times. Hence, we have this one here, B, being the one that is equivalent to 3/10, because when you simplify 30 hundredths, you get 3/10.
Thank you, Ms. Williams. And so, students, I hope you realize the importance of having a good understanding of equivalent fractions. Notice what's asked in the question and notice the model. It's important that you're able to switch between a fraction and to simplify it. All right, very important. We can move on now to our second question. And it asks, what is a good estimate of the point E? Notice it says good. What is a good estimate for the point E? Now, before you start to race and type in the chat, let us take a closer look at what we're asked here. So I'm looking at the number line and I'm seeing the values. And remember, Miss Darby would have pointed out earlier, we talked about how to call these numbers. So we have 1 and 1/10. I'm seeing 1 and 2/10. Anybody else seeing any other value that they want to share? And I see the chat blowing up with some values that I'm not paying attention to, you know, because I'm not ready to see any answers yet. But can anybody tell me some other values that you're seeing on the number line? Stony Hill Prep, your hand is up. Go ahead and tell me 1 or 2 other values that you're seeing.
All right, so Stony Hill Prep, you're on, go ahead. They have been unmuted, but I'm not hearing.
I'm not hearing. All right, Toilet, go ahead.
What's the name of that child?
Khalil Hoylett. I hope I got the pronunciation right.
Okay, great, no problem. You can unmute now, Khalil.
1.4.
Sure you want to say 1.4? That's how it's written, but how we call it? That 4 is what? 4 what?
You can unmute and speak.
400, 4/10,
A quarter.
Pardon?
4.
I am hearing something there.
Yes, I'm not.
Did you hear what he said?
Yes, it sounded like a quarter. Did I hear correctly?
Yes, you did.
Okay, so remember
that needs some fixing.
Pilot, right? So if we're looking at that 1 to the left of the number would be speaking to 1 whole, and that value that comes immediately after the decimal point, notice what we spoke about earlier and the demonstration that we did with the whole and cutting cutting it up into 10 equal parts. Remember how we wrote that as a decimal. It's 1 part out of 10 parts. And so that was written when we're using the decimal point as 0.1, meaning no whole at the time and 1 part out of 10 equal parts, okay? So when we're looking at 1.1, let me say it how you said it earlier. If you're looking at 1.1, it is really saying to us 1 whole. Thank you, Miss Williams. She's putting a little mark there. That one is telling me that there is 1 whole. And the other numeral is saying to me that I have the other digit. Thank you. What did I say? Thanks. The other digit is saying to me 1 part out of 10 equal parts. All right. 1 part out of 10 equal parts. Awesome. Thank you, Miss Williams. So let us run down to the one that the young man was trying to tell us about. So let's go down to 1.4. That's the one he chose. All right. What would that one be saying to us, Miss Williams? What does the 1 to the left of the point, what is that saying?
All right. So just like 1.1, it speaks to the whole number. How many holes we have there? It is saying that we have 1 hole. So the number in front of the decimal point speaks to the whole. So we have 1 hole here. And then the number after the decimal point speaks to the fraction. All right. So we have here 4.4. Yes, it is. And this is now 4 out of 10 equal parts. 4/10 it is. And this is based on our number system. We use a base 10 number system, right? And so if you were paying close attention to the diagram that was shown at the beginning of entering into our numeracy sample questions, you would have seen how that square was divided into 10 equal parts. That's how we started out. And so the fact that we have 1 decimal place, 1 number after the point, we're speaking to tenths. All right, so we have 1 whole and 4/10 here.
All right, thank you, Ms. Williams. There were some persons clarifying in the chat as well. Awesome. So let us remember how we say the number. It's very important because it helps us in understanding what the number really means and what value it is representing. All right, now let us get back to the question. I hope I would have cleared up the young man just now. Any other member of the team wants to share anything, or do you think we have dealt with it adequately?
I think we have dealt with it adequately, and now we understand that the number name is 1 and 4/10. So we see 1.4, that's what we see when we look. But when we call the number name, we say 1 and 4/10. In the same way that numbers that have thousands and so on, whole numbers, we don't call each digit by itself. We would say 1,340 something or whatever it is. In the same way, when we are calling decimal numbers, you don't call each digit. You call the value of the digit. 1 and 4/10 would be the correct name.
Thank you so much, Ms. Darby. Much appreciated. All right, so let us see if we can get into the nitty-gritty of the question, because we're asked for a good estimate of the point E. All right, and I saw some answers in the chat. So I'm looking at E and I want someone to tell me, unmute and tell me what 2 values is E lying between. What are the 2 values that E is lying between, immediately between? So let me see which hand is up. Stony Hill Prep. All right, that hand went. Okay, the hands are moving so quickly. Alan.
So that's Kaylin and Carissa.
Kaylin and Carissa.
You can unmute.
Please. So between the two digits, the E is pointing 13, 14. It's the E is in between 1/3 and 1/4. And
All right,
It's-
Kaylin
Alright.
and Carissa.
Go
But
ahead.
Miss Mundell, Thomas, did you hear how they read those two numbers?
I heard.
Okay, so we now need to shed some light on that. Remember, Kaylin and Carissa, look at the number there. 1, there is a whole number, 1, and so we should be hearing that. The 0.3 is 3/10. And so when we read the number, it is 1 and 3/10. I admire the fact that you're trying to read the number using the number value and number name, but you have to do it correctly. So we have 1 and 3/10. And the other one would be, I wonder if you could call the other one for me. Kaylin and Carissa, you want to call the other one for me? It's between 1 and 3/10, and what's the other number?
1 and 4/10.
Excellent. I love that. I love that. Great. You may
Awesome.
continue.
All right, so we're gonna carry on quickly. So now that we established that E is somewhere between 1 and 3/10 and 1 and 4/10, we're gonna just zoom into that section of the number line. All right, so on your screen, you're seeing just that piece of the number line pulled out. And Miss Williams, I'm gonna further divide this section of the number line, or I'm gonna divide the whole into 10 equal parts. So I'm cutting again this number line, each of those intervals, into 10 equal parts. All right. Now, if you remember the model we had earlier, whenever we went ahead and divided each 10th into 10 equal parts, we actually ended up with the whole being divided into 100 parts. All right, so can anybody tell me what would be the value for one of those intervals? Miss Williams, could you highlight an interval, please? What would be the value for one of those intervals? Just one of those intervals. And I see people typing the answer. But just so that the others are clear. Nobody's answering what I'm asking. Everybody answering the question at the top. Interesting.
And I
Miss
like the
Williams.
fact that I like the fact that you pointed out that no one is answering the question that you're asking. And so I want to pause at this moment to say, children, it's very important that you listen carefully, read carefully, and follow the instruction. Follow the instruction that is given, because you have to be precise in the answers that you give. Even though we're in a session here, yes, this is teaching us a lot. It's saying a lot. So please pay attention to the question asked, follow the instruction. And I want to see that coming out after this pause and reminding you that as you listen, just respond to the instruction. Go ahead, Miss.
All right, thank you so much, Miss Williams. All right, so if you remember earlier, said each of those, whether it's a number line we're looking at, or it's a square that we have divided up into 100 equal parts, the name is still going to be hundreds. All right, and so 1 and 3/10, we didn't have any hundredth there, and so we could actually represent that 1 and 3/10 as 1 and 30 hundredths. All right, so that should come in shortly. And similarly, 1 and 4/10, there are no hundreds there, and so it could also be written as 1 and 40 hundredths. In other words, there were no extra hundredths left over. All right. Now, I saw some answers coming in the chat, and so we can speed along a little, Miss Williams. So if we know that each of those represent now 1 hundredth, then we can easily add on hundredths as we go along. So we can now see clearly what these values would be. So we will have 1 and 30 hundredths. The next one would be 1 and 31 hundredths, and we continue. Now, based on what we're seeing on the number line, where was E? Where was E? Now is the time that you get to type in the chat what you think now the answer would be. All right. Saw some values. I'm not sure if there were typo errors in there. All right, so let us look. So my next question is, was E closer to 1 and 3/10 on the number line? Closer to 1 and 4/10, which is it? Is it closer to 1 and 3/10 or closer to 1 and 4/10? Any ideas? And somebody says none. All right, I'll take that. All right, so we could say, Miss Williams, that E is equal distance. All right, and somebody else says it's equal distance from 1 and 3/10 and 1 and 4/10. Awesome. All right.
And so long before you were finished, the answers were just lighting up the chat. Great.
Yeah. All right, so we can move on.
Just before you move on, please, Mrs. Mundell Thomas, I found it interesting that when you asked for what the interval was, a number of our students were saying 1/10. And that's something that we need to look out for, because if you're going from, if the interval itself that we started with is from 1 and 3/10 to 1 and 4/10, that in itself is 1/10. So immediately, the smaller divisions that you just created could not be 1/10 as well. So we want to be thinking about the reasonableness of our answer and whether what we're thinking is making sense. So I just wanted to just bring that in right there, because I saw a number of persons responding when you asked about the value of that each interval in this smaller interval meant. I got the impression a number of students were saying 1/10. So they were missing the point that the larger one was 1/10, so the smaller one could not be 1/10 as well. Just thought I'd bring that out as well for our students who were saying 1/10 initially. Thank you.
Very important point, Ms. Harris. And I do suspect that they are looking at the part that was zoomed out and seeing 10 intervals there and not realizing this is not the whole. As you rightly said, this is just 1/10 that is now being divided into 10 more equal parts. So very, very important point. Thank you for that. All right, so we move on to question 3. All right, so this question reads, what is the value of D in the equation? And we have 5 and 4 being added together, and that's equal to D and 1 being added together. And the question, of course, reads, what's the value of D? Now, before you get to answering, Lawrence, and I see quite a number of values coming in the chat. And I know you would jump and answer, you know, but I want to ask you first of all, what does the equal sign say to you? What does it mean? What is it saying in this question, or in any question for that matter? All right, so stop telling me the answer and tell me, what does the equal sign mean? What does it tell you?
So Jonathan Anderson typed in the chat that the equal sign means the answer.
Okay.
All right, let's give Vald a chance to share. You can unmute and speak with us.
All right, so there's some feedback. I think there may be more than one device in your space.
I'm going to ask you to mute the other devices. All right, let's give Dominique Dominique Allen a chance to tell us?
Go
Dominique,
ahead,
you may
Dominique.
unmute.
It means 5 plus 4 equals 9.
So what does the equal sign mean?
It tells you that the is 9 because the equal sign shows that.
Okay, I am hearing him clearly. It tells you that D is 9 because the equal sign shows that, but I'm still not getting what does the equal sign means to you. All right?
All right, let me see
Luke?
if I think I saw some things coming in the chat
Okay.
earlier. Some person said what it is equal to. Someone says it tells you the same as. Someone else says it means the same. Someone says the answer to the equation.
All right. Awesome. So we need
All
to
right.
explore those.
All right. So let us see if we can understand, before we get to answering the question, we need to understand what does the equal sign mean. So I'm going to pull the answer out of the chat that I think represented very closely what the equal sign does tell us in mathematics. All right, students, so whenever you see the equal sign, it is saying to you that whatever quantity is on the left-hand side is the same as, or has the same value as, everything that is on the right-hand side. Please stop typing in the chat and listen to what I'm saying, because this is very important. I'm seeing several incorrect answers in the chat right now. So I'm going to ask you to pause answering and pay attention. This is very, very important. And this information is going to follow you right up to high school, right through life. All right? So just pay attention. So let me repeat. The equal sign is saying to us that whatever value is on the right-hand side, the whole right-hand side, circle the whole right for me, Miss Williams. The whole right-hand side, everything over there.
Change your sides, miss. Change the right hand to left hand, please, Mrs. Williams.
Thank you so much. I'm left-handed. Can you imagine? Thank you so much for that, Miss Carol Harris. All right.
Whatever is on the left-hand side is
So I'm going to
equal
make
to
sure.
what is on the
Awesome.
right-hand side.
Quickly fix that before I have to shake my hand and say, oh yes, this is the left hand and this is the right hand. Thank you so much for that.
All right, so let me repeat for the benefit of the students once more. Here we go. So the equal sign is saying to us that what's on the left-hand side, all of what is on the left-hand side, has the same value as all that is on the right-hand side. It says that they are equal, equivalent, let me not use equal, equivalent, they are the same value. All right, so think about a scale. I think Miss Williams should have a balance somewhere there that she could bring up.
You want me to go to point theta for you?
Not necessarily, you can bring up what's on the,
okay.
All right, so here we have what we would call a pan balance. All right, so the equal sign is saying both of those sides have the same quantity in there. All right, that's what it means. Okay, so can anybody, bright student, tell me in the chat what's the value on the left hand side of this equation that we have on screen? All right, Shantavia was quick. Shantavia was quick out of the blocks, and I know you know this. 5 added to 4 is equal to 9. So the left-hand side is equal to 9. Therefore, the right-hand side must also be equal to 9. The whole right-hand side, the whole of it must be equal to 9. In other words, D plus 1 together must be equal to 9. The whole of it must be equal. You see how much time I'm saying it? And this must ring in your head. It must be equal to 9. And the question is asking us for the value of D. Just the D. The D. And we know that D added to 1 is supposed to give us 9. I see some people self-correcting, miss, but just to nail it down, we can run to toy theater.
Okay,
and,
not a problem.
and model over there so they can actually see what's happening with the pan balance. And then we can move on.
All right, so let's see what toy theater doing for us. And in
And
the
when we go to toy theater, if you notice on the balance, the two sides are at the same level. So that means the two things are, though the two of them are empty. So there's the things in there, the air in one is the same as the air in the other. They're the same thing. If one
And I
side
think
had
we have
dropped,
some blue things to put in them too, you know, maybe if you click.
yeah, but the blue, when the toy theater.
Yeah.
So let us
I
Oh,
think
you're
see.
so
Miss
right
Williams
about
may be
that, because
having a challenge with the internet.
are you hearing me clearly?
Yes, I'm hearing you.
Right, and so it seems as if the internet is just being a little naughty. I'm hoping that it will allow me to move on to those blue things that Miss Hazel McNeil Darby spoke about, because it's just going around in circles. But nonetheless, we can go ahead. Let's see. You can continue with your explanation.
So we were making the point that when the balance has both sides on the same level, it means that the quantity in each side is the same. If it had tipped over in one way or the other way, either way, remember when you're in grade 1 and it asks you which one is the heavier one, and it's the one that got tip over to the side, whichever side it tips to. So if it's going, whichever side it's lean over on, that's the heavier side. But once they're on the same level, that means they're in the same value.
All right, so we're going to demonstrate what you're talking about.
Oh, we're ready now. Great.
Wow, somebody stopped me from sharing.
Hush,
All
that
right.
was me. I'm helping you out, darling.
That's okay. It was
All
up and
right.
ready for you. Good.
Oh, it's up? Okay, let me
It
just
was,
do
but
this
go ahead.
part and hand it back to you. Notice what's happening, boys and girls. I've dropped 5 over on the left-hand side. And let's see what would happen if I put, let's put 4 over here. What is that saying to me? Are the values on both sides the same?
Let's see who is well. You can raise your hand if you want to
Right?
share.
People
Okay,
are
I'm
saying no
seeing
in the
the
chat.
book. Exactly.
Good. Which is the greater value? All right, and we notice it's tipped lower. Good, so the greater value is gonna tip lower than the lighter, the less value. Let me model what we had on screen. So we had 5 added to 4 on the left-hand side, and some value which we didn't know was added to 1 on the right-hand side. So right now, it's not balanced at all, meaning these two quantities, the one on the left and the one on the right, are not equal. Somebody said put 9. And you know I'm going to put 9, don't Miss Williams?
I know
Of
you're
course,
going
I'm
to
going
do
to put the
that.
9. I am
And
going to put the 9. So you're saying 9 is representing D because it said D plus 1. Is the 9 correct?
I'm seeing Shane saying, no, miss, put 8. But let us, you can talk to them about what's happening as you
All
put
right.
9 on the right-hand side.
All right, let's look at the values. So on the left-hand side, 5 added to 4 would have given me 9. But look what's on the right-hand side. 9 being added to 1. And of course, as we said earlier, this now becomes so heavy. It's tilted way down, telling us that these are not equal. So we could not use an equal sign there. Somebody said no, put 8. Let us see. What do you see, Miss Williams? Tell me. As maybe I'm wearing glasses, so probably I'm not seeing right.
Well, I am seeing that you're now balanced.
Oh, I
It is
am.
now
Am
balanced.
I?
Yes, yes. I'm seeing that both sides of the scale are really sitting in equal position. None is
I
lower
see.
than the other.
Okay. So I know why some students, I want to stop sharing and allow you to go back to the PowerPoint. But I know what some students were thinking when they said D was equal to 9. I hope they are clear now why D could not be equal to 9. Just waiting on it to come up so they have the visual.
All right.
Mhm.
So let's get down to that slide.
All right. So you should now be seeing, all right, and Nigel is putting it in the chat. Good. So I hope you're seeing why D could not be 9, because the entire right-hand side needs to be equal to 9. And so D alone can't be 9, and then you got to add 1 to it. That's not gonna keep the balance that we need. All right, boys and girls, let me know in the chat if you're following what we're saying, and by doing so, give me what D really should be, or what it is equal to, what's the value of D. Awesome. I see some people fixing their things. Beautiful. All right, great. I think we can move on, Miss Williams.
Definitely. All right, so we will reveal that.
So we have 2 more questions to go. We hope to finish those maybe in another 10 minutes and then see how far we can get you in a little bit of performance task, all right? So just bear with us. All right, question number 4. Stefan's watch shows 5 minutes past 9. His watch is 12 minutes fast. What is the correct time? And before you tell me and work out what's the correct time, the first thing I want to ask you, based on what is happening here, so his watch is showing 5 minutes past 9, but it's 12 minutes fast. Is the correct time earlier than 5 minutes past 9, or is the correct time later than 5 minutes past 9? Let me know in the chat, earlier or later than what is shown on his watch. All right, so Miss Williams, some people saying earlier, quite a few, but there are some people saying later.
Right, and I'm seeing quite a few earlier, and I'm seeing later also.
Later.
All right.
Let's see if we can address this. All right.
Luke has his hand raised.
Oh, go ahead, Luke. Sorry about
No,
that.
Luke has not joined with his microphone, and so Luke won't be able to share with us. Luke, look on your device. You see a headset. Perhaps if you hover
He would
over
hear
it,
us.
yes,
You
you
may
see
need to
dial
type it
over
in the chat.
internet, and you could select your microphone. But in the meantime, I am seeing Kenelia Taylor. Kenelia, could you explain to us your answer? Tell us your answer and explain. That's Kenelia Taylor from Lawrence Davern Primary.
I think she just lowered her hand.
She changed her mind.
Yes.
She changed her mind. All right, let's see someone else. What about Kensani? Kensani Doyle or Doyle? Yes. Kensani, please unmute and share with us your answer and explain. Kensani. Kensani Doyle? Go ahead now.
Later, because then you add 5 to 12.
Say that again. It is
Later
an
because
okay, you're saying later. Go ahead.
Because
I said later because I added 5 to 10 to 12.
or you're saying you added 5 minutes to 12 minutes and you're saying it would be a later time. That's what you're saying, Kensani?
Yes, miss.
Okay.
So what
Okay,
time
thank
would
you for
that be
sharing.
though? I'm wondering what time that would be for Kensani. You could probably type it in the chat. All right.
But I
So
want
Miss
to know,
Williams,
Miss Williams, I want to know because if my watch is fast, what is that saying to me? If my watch is fast, when my watch reaches to, for example, 8 o'clock, would it be 8 o'clock yet in real time? You tell me, because I want to ensure I'm thinking through this question.
And then, Mrs. Mondale Thomas, I'm saying if my watch is fast, should I go faster to get the time or should I slow down? That's what's on my mind. My thing is already fast. If I want to find the actual time, should I go faster, go ahead, or should I slow down, go behind? Those
let's
are the
hear.
questions in my head.
Great. All right. And now that you have whet your appetite, Mrs. McNeil, let's hear from Xavier Brown. Xavier, you may unmute. That's Xavier Brown. Go ahead.
Missy would be 9 minutes, 9 hours and 5 minutes earlier.
9 hours. Check that out. 9 hours. You know what you're talking about when you said hours?
Because miss, if you check, if it was 12 o'clock in the night, it will show 12 hours. So if it was 9 o'clock in the night, it would be 9 hours and 5 minutes earlier.
Okay. So I see you're focusing on the hours there. All right. But would your answer be showing an earlier time or a later time based on the information given here? Xavier, go ahead. It would be an earlier time. And we're going to clear up the hours and the minutes that you're talking about as we go along. But I'm glad you understand that the time would be earlier. Mrs. Mundell Thomas?
Thank you, Miss. All right, so I saw some hand, but in the interest of time, we want to ensure that we get you prepared as much as we can. All right, so let us stop, think it through. Mrs. Darby asked a very important question earlier, and I want us to just pause for a minute and think about it. So my watch, consider, you don't have to use Stefan in here, you can say my watch. My watch is showing 9 minutes past 9, but it moving too fast. That's what Miss Darby said, it's moving too fast. It really need to slow down. Am I to go forward or backward? That's the real question, That's the real question. Because he wants to know what's the correct time. If somebody asks him the time and he looks and says 5 minutes past 9, he would be giving them wrong time because he watched too fast. So let us see if we can go on Toy Theater, Miss, and see if we can help them.
Let's see. Just make sure you have your screen on standby just in case the internet is not so fast.
Right.
It is coming along, but it's moving a little slowly because there are so many persons on the platform, and so it has a wider jump to make. But you can get your screen on standby and you can share Toy Theater from your screen. All right,
Oh, it's
go ahead.
loading too.
It's
I
loading.
thought it was finished. My bad. All right, so yours may come up faster. I don't know what's happening on this end too. All right, so we can use the PowerPoint in the meantime while this comes up, because there's actually something on it that could help us while we wait on this part. All right.
All
Let me
right,
stop
so
sharing. Mhm.
let me
Go ahead.
escape a little myself. Are you still sharing?
No, I'm not.
All right. So my internet is a little bit, let's close this and move right along.
All right, so while you're bringing it up, I saw some persons mentioning backward in the chat. Vlad, I hope I got that pronunciation right. He's saying if the watch is 12 minutes ahead, then he needs to subtract 12 because it's way ahead. But he needs to go back, he's saying. See if there's anything else.
All right, so I'm coming up with that presentation for you.
You're not sharing.
I realize I'm not sharing. All right. And so,
All right, let me try. Let me go ahead.
no problem.
Mhm.
And as you do that,
All right. So we are saying, students, that his watch is 12 minutes fast, and so it's going, as Miss Darby says, it moved. It was giving us a time that is later than what the correct time is. And so, as some of you pointed out in the chat, we really needed to go backward. I saw some answers in the chat. All right, we didn't take them because we weren't quite ready for the answer. But let's watch what's happening here with the animation. So we're gonna have to go back 12 minutes. Now, this is just a picture, which is why we wanted to show you on Toy Theater an actual animated clock that would move along with us. All right, but in the meantime, we use what we have. All right, so we're gonna go back 5 minutes, which is gonna take us to 9 o'clock, and you're gonna tell me the rest. Another 5 minutes back. Let me bring up the chat. What time would that be now? So I've gone back 5 minutes and then another 5 minutes. Just type in the chat quickly. What time would that be now? All right. I see someone saying 8:55. Oh, okay, or 5 minutes to 9. All right. And so it was 12 minutes past. So we still have to go back another 2 minutes. Let's see if we can get that in. All right. Another 2 minutes. And I see the correct answer popping in. Some persons had given it earlier. What's the time now? All right, some persons have 8:53 or 7 minutes to 9. I'm so sorry, guys, that you're not seeing the Toy Theater, but what
you
we'll do,
can, they can see it now, miss.
you have it now, miss?
Yes, I
Awesome.
can, yes. So let me just
All right,
quickly
so let
get
me
to
stop.
it for you. All right, where's that one with the clock?
And then we do the last question and end here at 12:30, and we use the half hour to look at the performance.
Are you seeing my screen? Okay.
No, I'm not. I was still
Right.
sharing.
So let's go.
So while that comes up, just to say that if we say that the clock is fast, you can't go faster. You can't
Sure.
keep going forward if it is fast. You need to slow down, and the only way to slow down is to go back, to put back the hands of the clock. All right, go ahead, miss.
All right, so we were at,
Can we get a color change, miss, so they can see what's happening with the minutes hand?
no problem. So we were at 9:05, right?
5 minutes past, yes.
5 minutes past 9. Great. All right, so there it is. And you're going. So watch, just look at the minute hand, dear children. the orange one. I want you to look as we move. So we were at 5 minutes. Let me go back and look at the intervals in between. These are the little strokes. We're coming from that. And so I wonder if anybody could tell us what one of these strokes or interval or strikes, whatever you want to call them, represent on the clock. Type it in the chat. Miss, as you see typed in the chat, let us just.
All right, some persons are saying 1, they didn't put a unit, but there are others who are saying 1 minute.
1 minute.
1 minute, great. So we're going back 1 minute, 2 minutes, 3 minutes, 4 minutes, and then 5 minutes. And look at what time we're at for 5 minutes. We are at 9 o'clock. Look at the hour hand, dead on the 9. So that's 9. Now let's go back another 5 minutes. Wow. Watch what's happening with that digital or that broken line on the hour hand, the hour right there on 9. It is also shifting as the minute hand goes back. And look at that. It's no longer on the 9, very close to it. Reasons being for that is that it's close to 9 o'clock. So it's not 9 o'clock. And I noticed I saw persons typing in the chat 8:53 and so on. I also saw one person who typed 9:55 as we were going back. Remember, we're going back to the next hour. So let me move now 1, 2 more minutes, making it 12 minutes. We have gone back 12 minutes and look at the new time. The hour hand is close to 9 and it is saying it is actually past 8, but going to 9. And hence we have the time. You want me to reveal it on the digital, Mrs. Mondell Thomas?
You can go ahead, no problem.
All right, so here we have it on the digital. It is telling us that it is 8:53 a.m. So please note that as you shift from 1 hour to the next, what is happening. All right, over to you now, Miss.
Hold on, Mrs. Williams. You are
Good.
telling me that although the hour hand is pointing on 9, the hour I call is 8?
So, Miss, if you notice, I want you to look. There is a circle with broken lines around the 9. And through that circle, there is a broken line, which is showing you the hour hand. If you notice, it is not dead on 9.
So it's not yet
So it's
the 9th
not
hour
yet
of
9,
the day.
no.
It is the 8th hour of the day.
Exactly.
So it is 8:53.
Yes.
Wow.
And I want to point out to you
That's true.
that it is farther away from the 8, but it is not yet 9.
On the 9.
It is
It
still
is
going to the 9.
8:53, although it is pointing on the 9 or close to pointing on the 9. So it is coming up to the 9th hour, which will happen when the minutes would be 60. It would be on the 9th hour.
Exactly.
Take it back up. Let me see what
I want to
happens.
take it
It's
back as we
amazing.
go down. Look at the
No,
time.
no, go back up to the hour. Go to on the hour. Go on the hour. Go on the hour.
I want to shift a little for you to see what is happening. Here we are. Look at the orange hand, which is the minute hand. It is on 8, where it's showing 8 minutes. Yeah, 40 minutes rather past the hour 8. And look where the hour hand is. Yes, it moves closer to 8. Let's go back now as we're moving up. We're moving up. Look at what's happening. Look at those 2 circles over there, how they have overlapped, showing that we're moving closer. As the minute hand moves, so does the hour hand, slowly but surely. And I'm taking it up. Look at where the line is when it comes onto the hour hand. Very close to 9, but not yet 9 o'clock. We are at 8:55, still very close to 9. And look as it moves. Look at it. Look as the minute hand moves closer now to 12.
And it's on the hour. This is amazing. I like
on the hour, showing that it is 9 o'clock. And children, sometimes you are asked to put in the hand on a clock to show the time. And when it's way past the hour, your hour hand is still dead on the hour. I want you to look at what happens if I should move this minute hand around. look at how the hour hand is also moving
That's
away.
the black hand.
The black hand, thank you
hand.
so much. So
Okay.
as the minute hand, which is the orange hand, moves around the clock, so is the hour hand moving away from the 9th hour and showing that we're getting closer to the 10th hour. Look at what is happening here. You might not see this on your clock, but this is what is happening as we go along. And look at that. They pass each other and dead on the hour, on the 10th hour. All right.
Thank you very much. I like
Awesome.
this. Thank you.
All
Awesome
right.
stuff. Thank you, Miss Williams. So we jump now to our final question for the numeracy part, which is, you know, a question to take us down, you know, smoothly. So
All
let
right,
us go.
great. You're seeing my screen, right?
Yes, I am. Yes, I
And
am.
so the answer revealed.
Mhm.
Great.
Oh.
And I hope
All right,
somebody
let's
answered.
the
All right,
table
going a little
below.
bit too fast.
The
All
table
right.
below shows the number of pages each student reads during the school year. Each star on the pictograph represents 50 pages. How many pages did Liam read? So Liam is in the pictograph at the top there, and we're given our key. It's said in words, and it's also on the pictograph. How many pages did Liam read? And so for this one, I'll allow you to put your answer in the chat, but be prepared to share how you got your answer as we end this part of the presentation.
So I'll tell you what's going on in the chat.
The first
seeing-
answer was actually 10.
I'm seeing D,
Interesting.
and I'm seeing 450. I'm seeing 400, yes, 450. I'm seeing 425, 425, 450. I'm seeing C, and I'm seeing 475. So we have,
The answers are all over.
yes,
the
they are
place.
all over.
All
So
right,
I'm
let's see if
still
we
seeing
can.
400, I'm still seeing 425, 450, and 475 coming in. All right,
Miss
nobody
Williams,
is
Plus the
seeing.
answer 10 that was not there at all.
that was
Awesome.
okay. I think that 10 came just as the question popped up. I'm not sure if it was for this question or if it was while we were showing the clock that Miss was doing.
All
No,
right.
man, when you were doing Toy Theater, I think it came in
Okay.
at that time.
We're not so
All right.
sure. So
Yeah, man, I
let's
was looking at the chat.
All right, great. So here we are.
So bring up your laser, Miss, because I really want us to get into the performance task. So I'm gonna just allow you to just bring up your laser and we are gonna count together based on the key that was given. So we're told each of these stars value 50. Ms. Williams, I hope you can count by 50. Make us see if you
There
can
we
count.
go. All right.
Let's see. All right, so let's go to Liam.
This is 50
50 and another 50.
That's
100.
100 plus 50.
150
plus 50. 200 plus 50. 250 plus another 50. That's 300 plus another 50. 350 plus another 50. That's 400. And another 50 is 450. But hello, what's happening to this star here?
Well, it's certainly not 50.
I hear somebody say it's a half a star. So if it's a half a star, what's the value of that half a star? If one
Right,
star is
the chat is blowing up. The chat is blowing up with 25.
So if one star is 50, then half a star is 25. I see that the chat is just like pepper light. It's going, yes, just lighting up. So we're agreeing that this star here is a half a star. And if it's half a star, then it is half of the 50 that's there. And half of 50 is really 25. Awesome.
And we were at 450, correct? So far.
Yes, we were at 450. Great.
Okay.
So that's
so we needed
450 plus These
Plus that
25
25.
here, making it 475. I
Awesome.
want to point out here to our children who will be doing your exam, or grade 4 children, this is your foundation grade. And this is where we expect you to start paying close attention to details. Don't just rush to give an answer. Make sure you examine or observe what is given so that you can see the little tricks and the little hidden things that will now help you to see that we don't really want to trick you, but we want you to pay
Be
close
careful.
attention. Yes, pay close
Be
attention to
careful.
what is given and make the best choice. All right? So yes, we have a half a star. You must see the half a star. Don't miss it. Okay. Over to you, Mrs. Mundell
Thank you
Thomas.
so much, Miss Williams. I know we've been sitting a long time, including myself. So wherever you are, students, just stand right in your seat, and we're going to stretch a little bit and then see how far we reach. Wherever we are in the performance task, we'll take that, but we want to take you through as much of it as possible in the remaining time that we have. But it was a fruitful morning, and I do believe you would have benefited from what was shared. So stand where you are, and we're going to be stretching up with your hands. I hope you're seeing me. I haven't stood, but I'm stretching up with your arms. Yes. Forward. Sideways. Yes. And if you have enough space, you can go backward with your arms. Bend and touch your toes. Yes, because you were sitting for quite a while. All right. Shake it off now. And sit back in your seat. How you feeling, Miss Williams?
Awesome. I'm just feeling great. I'm ready to
Okay.
go on.
Ready to go. All right, good.
Exactly.
All right.
So we're
So we
moving
have
on
achieved,
to-
we have achieved the first objective that we set out to, and we're now going on to the performance task, which is a more problem-solving idea. All right. So let's see if we can get into it. Now, the task today is entitled Colorful Walls. And from the picture, you know, it has something to do with painting. All right. So we may not have you talking a lot for this part because we really want to show you what the performance task looks like. I know you're at grade 4, and this will be your first official performance task. And so we want to share as much of it as possible with you so you can see the thinking that is required. All right. So here's the task. Your dad, Randy, is painting a room in the house. Each wall surface to be painted has the same area. All right. Notice. And I know we didn't share a 3-read strategy with you today, but you may need to read it again to, you know, see what it is saying. All right. Now, your father asked you to help him with the decisions relating to the painting of the room. All right, so remember we said performance task, problem-based, which usually mean you have to do some decision making. All right, and you're gonna use the map to help you. Now, they say these are the colors that Randy wants to use for the room. He says one wall will be purple, one wall will be beige, and 2 walls will be blue. Don't worry so much about the beige. You might not know what that color is yet, but we'll give you a visual just to give you an idea of what shade. But it's a kind of a pale brown creamish idea. It will come up on screen shortly. All right, but don't worry about that part too much. Let's see if we can answer what's asked of us. So the fraction we're asked, what fraction of the walls in the room will be blue? Now, students, when you get the question, think to yourself, what information have I been given? All right. So you ask yourself, what information have I been given? And we also have that on the slide. So you will see it pop up. What information is there? So before you get to answering, you have to think it through. And I see some answers in the chat. All right. We'll pay attention to that in a minute. Now, there was something that was said earlier, Miss Williams, that is very important. It's not
Yes,
on
it
this
is.
part, but it was in the introduction of the task.
You want me to go back so they can see
You
it?
can go back, you
I
can
certainly
go
will.
back. There was
Here we
something
are.
important. Can anybody tell me, look at it and see if you tell me what piece of information here is important in answering what was asked about the fraction of the room, fraction of the, what fraction of the walls in the room? I think that's what it said.
Yes.
Would
It's
be
shaded
painted blue.
be colored blue or painted blue, yes. I'm wondering if these hands that are up, if they really
All right.
want to respond to that question.
Go
All
ahead.
right, so I'm going to ask Davario Marshall. Davario, you may unmute and speak with us. All right, so Davario. All right, still
The hand
waiting.
went down. Mhm.
Let's look at Lawrence Tavern. Lawrence Tavern Primary, go ahead and tell us what bit of important information is given here that will help us to figure out what fraction of the wall is shaded blue, or we need to use in order to come up with the answer. Lawrence Tavern, are you ready? You're asked to unmute. Please unmute and speak with us. All right, so we're moving away because we really want to cover quickly. Are you ready now?
2 out of 4.
Didn't hear that?
He said 2 out of 4. They're giving us answers.
No, we want
But
you to look
I
on.
see something in the chat though. So
Awesome.
I can't see who said it, but the person said each wall would be the same area. Chat is moving so fast, I can't find it back, but it did pop up in the chat where someone mentioned that
That's Michelle Swaby.
each wall, right, will be right, each wall to be the same area. Thank you so much, Michelle. Awesome. That's important.
Right.
It is important.
We will now go back to the slide that we were at.
Thank you. While you're doing that, so why is this important? You may be asking. Remember, when we talk about fractions, as we did with the sample task, we always nail home the point that it must be divided into equal parts. And so not because the room has 4 walls, that doesn't say that each wall would have the same paste, surface to be painted. All right, so the fact that that was mentioned is very important, and that will now help us. So if some walls were bigger than some, let me put it in layman terms, then we would have a challenge in expressing the fraction of the walls in the room that would be blue. All right, because we would need to know which particular walls, because some were smaller than others, and all of that would have to come into play. So it's important that we were told each wall is to be painted, the area of each wall would be the same. All right, now we can continue.
All right,
so let's go
I think
now.
you want to show them now what is happening. So that's the important bit of information that was really nailed. So let's show them what the wall looks like now.
So bear in mind, this large rectangle is actually representing the entire room. All right, so that's the whole. And we're now divided it into 4 equal parts based on what information was given earlier about the same area. And we have put in the colors. All right.
Awesome.
And I did see the answers coming out in the chat, so we can go ahead and just confirm. So the math you need is to understand fractions, of course, and recognize that the denominator is representative of the number of equal parts into which the whole has been divided.
And we saw this coming up in the chat.
Yes, we did. And we also saw a person simplifying it and giving us a half. Yes.
Very good. Right. So persons also gave us 1/2, which is shown here. Awesome. Excellent. So guess what? I like our grade 4. The future looks real bright. They are
definitely
really handling the fraction very well. So there we have it. let's move right along. Go ahead, Miss.
All right, so the other part to part one says, it takes Randy 30 minutes to paint one wall. 30 minutes to paint one wall. He started painting at 5:30 p.m. and stopped at 6:45 p.m. to eat dinner. If each wall takes the same amount of time, how many walls was he able to paint in that time? So we pause and we look back at the question and we try now to identify what information is given, as that's what we're going to be using to answer the question. So Ms. Williams, let's see if we can pick up the information that's given.
Okay, great. So that's one. 30
right,
minutes
very
to paint
important.
one wall. Very important. It takes Randy 30 minutes to paint one wall. We're going to need that. Look at when he started painting. That was given. And he stopped at 6:45. Very, very important.
All right,
info.
so
And
stick a
there's-
pin. Stick a pin. So
Sure.
30 minutes to paint one wall. We are given a start time. We're given an end time. So we need something in between to help us. All right, let's continue.
And it's right there. Each wall takes the same amount of time.
All right. All important points. And students, you see how we underline it? When you get your paper, if you feel you need to underline what's important, feel free to do so. All right? Not a problem with that.
And
Okay.
then we use this now to pinpoint what math we need to solve the problem, because you're asking how many walls was he able to paint between 5:30 and 6:45 p.m.
All right. So we need to have some understanding of time, Miss Williams. Yes?
Definitely.
We need to have an idea of if we start at such a time, when does 1 hour end? When is half hour after? Those kinds of things will come up as we try to solve the problem. All right, so students, we opted to use a little number line to help us. This is not the only way that it can be approached, just pointing out. All right, it doesn't have to be, but we are using this as one of the ways that you can solve it. So we have our start time, notice 5:30 is there. Our end time is 6:45. However, notice we're using our number line. We have equal intervals of 30 minutes. And we're choosing 30 minutes based on the question and what was said. All right, so it's easier for us in our calculation, in our thinking through the question and using the number line. It's easier if it's in 30-minute slots, because it takes 30 minutes for Randy to paint one wall. All right, so we have 5:30, then next up would be 6 o'clock. So we just did a clock activity earlier. So we see half hour later is 6 o'clock, half hour later is 6:30, half hour later would be 7 o'clock. But Randy stopped at 6:45. Now let us see if we can process how many walls was he able to paint. So we're gonna do some frog jumps. We're gonna jump half hour, and we know that every half hour that passed, and I'm saying half hour, but they say 30 minutes, but it's the same time period, not true?
Exactly.
All right.
It's just like our equivalent fractions, eh?
Thank you so much, Miss Williams. So let's do some frog jumps, Miss.
All right, so for the first half an hour, that's one wall.
One.
Exactly. And then we can get another half an hour. So that's another wall. Awesome.
But stick a pin, Miss Williams, stick a pin, because
certainly will.
I want to ask the students. So it is now 6:30. Randy has painted 2 walls from what I'm seeing here. He stopped at 6:45. Does he have sufficient time to paint an entire wall from 6:30 to 6:45? Is there sufficient time? Is there enough time for him to paint a whole nother wall? All
I
right,
would really
some
want
people
to hear
say
from
no,
somebody.
miss. Yes,
Okay.
go ahead. There's a hand up.
There's
Don't know
a
if she's
hand up.
answering this. Kenelia Taylor, Lauren, Scaver.
All right.
Oh, that's the school. Kenelia Taylor.
Please unmute Cornelia and share with us why you say no.
She's muted herself again, or it's been muted.
Let's help her. Go
Miss,
ahead now.
Miss, I think the answer is 2 hours.
No, don't tell us the answer. I'm going to stop you there. Notice the question that was asked. Do you think Randy has enough time to paint an entire wall? He's now at 6:30. He ended at 6:45. Is there enough time to paint an entire wall? Why or why not? Are you willing to share? You may unmute.
Her hand went down, another hand went up.
That's
Oh,
okay.
go
She's
ahead.
ready. She's ready.
Miss, he can't paint all 4 of them. He can just paint 2 of them.
And why is that so?
Miss, because it says that it took him 30 minutes to. Somebody is in there.
Keep going. Keep going.
It stated that he took 30 minutes to paint one wall, and 5:30 to 6:30 is 30 minutes. Then 6 o'clock to 6:30 is another 30 minutes. So that means he painted 2 walls, and then they jumped to 6:45 when he had to eat his dinner. So it is 2 walls and a half.
2 walls and a half. Or are you satisfied with that, Mrs. Mundell Thomas? Although the person tried to give us the answer, but I like the fact that the person was actually using the intervals of half an hour to calculate, you know, how many walls would have been painted. I still want to hear though, why the half? Where does that half comes from? Why did you stop at a half? I wonder if anybody wants to take it up from there. Why should the person stop at a half, or why did the person stop at a half? Any takers?
So I'm hearing them saying there isn't sufficient time to do a whole wall based on the time that's left between 6:30 and 6:45, and they're saying he can only paint a half of a wall in that time. That's what the person said, Miss Williams.
That's what I heard. Yes.
Okay, so why half? What would definitively, what would surely tell us that it's a half
of a wall? I see Xavier
of
ready
a
to
wall?
speak. Xavier, you want to share? Xavier Brown? All right, so he's probably not sure he wants to share. Karine Bennett, let's take one more. We'll try with one more. Karine Bennett, go ahead.
Excuse me, miss. I think that he could only paint half a wall because his parents called him for dinner, so he could only paint half of the wall during that time.
So why half? What is there to tell you that it's only half? Yes, we understand his parents call him for dinner. Yes?
Miss, it's because it's half of the time.
Half.
Okay.
Miss, it would be 6:30 to 7 o'clock, which is, and they called him at 6:45, which would be half of 7 o'clock.
Half there. And how many minutes would that be though? I want to know. I noticed you said 6:30 to 7 o'clock, and now you're saying they call him at 6:45, so it's half the time. So what does that half the time they represent? Give it to me in time language. What does it represent? Are you ready? Anybody wants to tell us what? You can type it in the chat. Other persons who wants to
I
help.
saw things in the chat. Yes,
Okay.
I saw things in the chat, Miss Williams. Person said because 15 minutes is half of 30 minutes. So a full wall takes 30 minutes. So you would only be able to do half of a wall. That was the essence. There were some others who
Beautiful
shared similar
explanation from
sentiments.
Nathan Sutherland, Miss. Beautiful explanation. I love
Yes.
that.
Awesome.
And let me just pause here to say, Mrs. Mundell Thomas, some in our performance task children, sometimes you are asked to explain how you arrive at your answer or why you would have really selected that choice. And we want to point out to you, we would have seen in the chat 2 minutes, 15 minutes, we would have seen 2.5 hours and so on. But I want to point out Nathan Sutherland's explanation. Very, very explicit. And I mean, it's to the point. 15 minutes is half of 30 minutes. So a full wall takes 30 minutes. So 15 minutes is a half a wall. And that's clear enough. And that is showing us that you can communicate your understanding in writing. So as PEP seeks to test or to assess how you communicate, this is how we are now imploring you and encouraging you to explain your answer clearly so that even a child at grade 1, when they read your answer, they can understand what you're saying. Over to you now.
As you mentioned that, Miss Williams, just a
Just
minute,
quick
they would
one.
notice. Okay, go ahead, Miss.
Just a quick one. I like how he said it, but then it just to be a little bit more precise. So 15 minutes, the time can't be half a wall. So 15 minutes is the time to paint half a wall. So that could just make it a little tighter. So the reason I'm saying that is that I noticed in the initial question when you asked about how many walls could be painted, a number of children are putting in a time answer. I don't know if you noticed that in the chat, but a number of our children are putting in a time answer for the number of walls. So look out for what should I be telling them? Should I be telling them something in time? Should I be telling them about minutes when I was asked about number of walls? So be careful as you answer your question that you're answering the question asked. Not because you say a lot of minutes in the question means that my answer is going to be minutes. They asked me about how many walls, so I should be telling them how many walls. Not 2:15, which is a time, not 2:30, which is a time, but 2.5 walls.
Excellent reminder. Excellent reminder.
A number of them said minutes. So look out for what is being asked, boys and girls, and be careful what am I being asked? Will number of walls be in minutes? No, it won't. So I cannot possibly be giving an answer that is telling them about minutes.
Awesome.
Okay, then back to Mrs. Mondale.
All right, so Ms.
Very
Mondale.
important point. Yes, thank you so much, Ms. Harris. Very, very important point. I was also adding to that, that not all the times, what should I say? Very deep calculations are required. If you notice how we answered this question here, we used a model to help us. All right. And so sometimes, remember earlier, we talked about problem solving strategies and how sometimes you can draw a diagram, sometimes you can, do a table, whatever it is, depending on the question that you have been given. And so for this one, we opted to do a model, so that a visual representation of what is happening and how we got our answer. However, in mind that a diagram by itself doesn't explain anything unless it is properly labeled and the information is there. So notice we had our jumps and we showed 1 plus another 1 plus, and I'm sure as Miss clicks, see a up total of 2.
Okay. So,
and as we look at the final slide, I notice we're up on the 1 o'clock mark. So as we look at the other slide, just to show you an alternative way that you could have arrived at an answer for this question. All right. So remember, you choose a strategy that's suitable for you. All right. So I may think to myself, so I'm doing the same question that you are doing. You decided to use a model and your answer is correct. I decided, I'm going to check from 5:30 p.m. to 6:30 p.m. That's 60 minutes. Notice, even though I'm doing that ahead, I am understands what my thinking is. So I've written it down 5:30 p.m. to 6:30 p.m. That is 60 minutes. And then I'm going to think 6:30 p.m. to 6:45 p.m. And I'm going to think, is that?
I do hope that it's not Mrs. Mundell Thomas. Are you hearing Mrs. Mundell Thomas clearly?
No, it's breaking up. It's very glitchy.
Okay, all right.
Any better? Are you hearing me any better now?
Better now. Yes, it's
Yes.
better now, miss. Go ahead.
I apologize. So let me just repeat what I was saying. So I'm saying I'm myself 5:30 p.m. is 60 minutes. And though I am thinking that, I am also writing it down so that the person who is reading my paper knows exactly what it is that I'm thinking. It is not okay to think it and then all of a sudden, all you have on your paper is 60 minutes. All right, or all you have on your paper is 75 minutes. It must be clear to the person what your thinking was. So I've written it down, and I've written down 6:30 p.m. to 6:45 p.m. and I've thought about it, and I know that's 15 minutes. It is there. And then I do my addition. I say, okay, so Randy now has 75 minutes to paint the walls. All right. Then I'm thinking, if it's 30 minutes to paint one wall, I need to think, how many 30 minutes could I get out of 75 minutes? Which operation, students? Last question I'm going to ask you. Which operation, if I want to find out how many 30 minutes could I get out of 75 minutes? Do you know of any operations that could help us?
You could just type it in the chat.
Divide.
Type it in the chat.
Someone said divide.
I see addition.
Someone said addition. I would like the students who said addition to perhaps unmute and tell us how they would use addition to help them. I didn't get the name.
Zachary.
Karam.
Zachary, you want to tell us?
I'm not sure.
How we could...
Let's see. Zachary did not join with his microphone. So perhaps we could do Karam.
Oh,
Karam, unmute.
okay.
Please unmute Karam. That's Karam Murphy. Please unmute. One last time, Karam Murphy, please unmute. All right, so Karam doesn't, okay, go ahead, Karam. Cameron Murphy.
That's
Miss,
answer.
Say that again, Cameron.
Miss, I put in addition.
Yes, why add?
I wasn't hearing you clearly just now, Miss.
Say that again, Cameron.
Division.
You have changed to division?
Miss, I made a mistake. I said addition is division.
Okay, so he has changed to division, Miss.
Okay, that's one. That's one operation.
Divide and addition.
Okay. So that's division is one operation I could use, yes, which is quite efficient. That's one. All right. Someone said subtraction too. All right, so maybe I could take away 30 and see how many times I could take it away. That's another option. Will take maybe a little more time, but an option nonetheless. But students, try to choose the most efficient way to complete your calculations. All right, and by efficient, it's the one that you use properly. All right.
And I want to point out something here, Miss Mundell Thomas.
Go ahead.
Okay, great. If you notice, different students came up with different operation. And we are not saying no to that. As long as you understand what the question is asking you for, and you show how you arrive at your answer by writing down everything on the paper, then we are okay with it. So person said addition, you'd have to show us what you're adding to get the answer. Person said subtraction, show us what you're subtracting to give us the answer. And person said division. So if you're comfortable with that, we have no problem. And some persons would say multiplication. The beauty about your performance task, sorry about that. The beauty about your performance task is however you understand the question and whatever strategy you want to use to help you get to a solution, that is what really matters. And just to add to what Mrs. Mundell Thomas said, we cannot see in your head, write every detail on the paper. If it's draw your drawing, draw and put in some information with it. You're getting marks for that, okay? Because that's communicating. Over to you now, Miss.
If we could just hear from Zachary, he's ready now to share. I'm curious to hear what the addition strategy would involve. Just quickly, because we're against the clock.
All right. So has Zachary joined with his microphone now?
Yes, he's with his microphone now. Go ahead, Zachary.
Would be addition.
What would you add?
Because you have to add 530 plus 75.
You'll be adding the start time to the number of minutes. So why would you be adding that to find out the number of walls? Walk us through that a bit.
I'm gonna ask you to unmute again, Zachary.
To a left side.
Didn't hear you clearly.
There's an echo from his device. There may be another device in his face, so we're not hearing clearly. But maybe after we can hear a little bit more.
Explore some more with Zachary.
All right, so students, this is not the end of the performance task, as we would have expressed. We're trying to take you through as much of it as possible. There are other parts that would require you to do a little bit more thinking. But one thing we want to share with you or leave with you is that when you get to, for example, parts 2 and parts 3, you may have to pull back on information that was shared in the first part of the performance task. All right, just as what happened earlier when we talked about the number, the fraction of the room that would have been painted blue. We had to pull back on the information earlier about the same area, same idea. You may get to the second part of the task, and based on what question is, maybe it's a question about color, right? They may not repeat the colors and how many walls need to be painted in a particular color. And so you may have to flip back the page to the first part to remind yourself, oh yes, it was one purple and one beige and two was supposed to be blue. Because you need that information in order to answer something that's later in the task. All right, but we have to stop here. Thank you so much for accommodating us. Mrs. Williams is strategically putting the next part on it so you can take a picture of it and you can go through the task with your teacher, all right, to assist you.
I did it because of the explanation that you were giving. And we're not going to go through this section, but as you rightfully pointed out, paints come in 1 gallon containers that cost $4,100 each. 3/8 of a gallon of paint is needed to paint each wall. Randy has $12,000 to spend on paint. Will he have enough money? So as you rightfully say, they would have to go back to part 1 to see the number of walls and the number of paint that is needed here. So definitely.
Right, and in what colors? What colors are needed in what quantities? Right.
Awesome.
All right, students, thank you so much for accommodating us. We will end the live stream and allow you to